The addition formula for sine A minus B is sine A minus B equals sine A cos B minus cos A sine B. So if I let A equal 90 and B equal x, then I will get sine 90 minus x equals sine 90 cos x minus cos 90 sine x. Now cos 90 is equal to 0, which means this term simply cancels out, and sine 90 is equal to 1, which means I can just eliminate that as well. And therefore, I've actually shown that sine 90 minus x is equal to cos x. Then asked to solve this trig equation. Now the right hand side, it can't really simplify that, so what I'm going to do is multiply through by cos theta plus 17. Because suddenly this looks an awful lot like a double angle formula for sine. So sine 2a is identical to 2 sine a cos a. And if I set a equal to theta plus 8, then I get, sorry, not theta plus 8, theta plus 17. Then I'll get this over here. So I just need to double it. It'll be, this here will equal sine of 2 lots of theta plus 17. And therefore sine of 2 theta plus 34 will equal this cos expression, but that's not that easy to solve. What we need to do is use part A to help us. So I can replace, I've got cos theta plus 8, so I can replace x by theta plus 8. This will become sine 90 minus theta plus 8, which equals sine of 90 minus theta minus 8, and therefore the equation becomes sine 2 theta plus 34 equals sine of 82 minus theta. Now, an immediate solution to this equation is if the values inside the signs are the same. So 2 theta plus 34 is equal to 82 minus theta. That means 3 theta equals 48. So theta is equal to 16 degrees. But that is not all. We need to now carefully find the other ones. So if I draw the sine function, what we could have is one of them equaling this value, let's say it's x, and the other one equaling this value. Now this is 180, and this is the same because of the symmetry of the sine curve. We've got a line of symmetry at 90. So this value here is 180 minus x. In fact, that's how you normally find more solutions. You know, if you had a sine x and sine of 20 equals whatever value you've got, then another solution would be sine of 160. But remember, we can't just do 180 minus 16 because we got that 16 by solving an equation. So I'm going to say that another solution would potentially be that 2 theta plus 34 is equal to 180 minus that 82 minus theta. See, one of them is taking the value of the x, and the other one is taking the value of the 180 minus x. And then this gives 2 theta plus 34 equals 98 plus theta. So theta by minus theta from both sides will equal 64 degrees. Then we've got ourselves a second solution. So when I put that back in, I'll get something over here. What will I get actually? When I put 64 in, I'll get 80, sine of 18 over here. And over here, 128 plus 34, which gives 162. See, and those two sine ofs will give the same value because they're 180 minus one another. Now I don't need to do it the other way around. I don't need to do 82 minus theta is 118 minus 2 theta plus 34 because it's the same equation. I've already dealt with it. Now, another way they could be the same is if one of them is over here, which is 360 plus x. That will have the same value as x originally. So I can say that 2 theta plus 34 equals 82 minus theta plus 360. This gives a very similar equation to what I had originally. 3 theta is going to equal 48, but now this additional 360. I could add them together, or I can just divide through by 3 straight away. Theta is 16 plus 120, which gives 136 degrees as another possible answer. And why stop there? Because if I carry on the sine curve, there's going to be another value here that's 720 plus x. So now 2 theta plus 34 will equal 82 minus theta plus 720. Very similar equation formed. 3 theta equals 48 plus 720. Divide through by 3. Theta is 16 plus 240 gives 256 degrees as a fourth answer. Now, where are we up to? We've looked at when the values in each sine function are exactly the same, and that got us the solution of 16. We then looked at when one was here on the sine curve and one was here, which is equivalent to working out when one is here and one is here, for example. Turns out if you then go for this one and this one, then you get a negative solution. So we don't get any more from that kind of approach. But we did then look at this original x and then 360 plus x, and that got us to 136. And we went a stage further and did these two being the same, and that gave 256. If we did another one, then it goes outside the range again. So the only other one to potentially look at, I think, is that original one. And then, oh no, I've already dealt with that actually. Sorry, I've dealt with that one as well. That gave a negative. So basically, we've looked at all the different possibilities. I personally think it's quite hard to keep track and know that we found them all, but these are the 4 solutions, and I hope I've been convincingly comprehensive. Well done.